All right, guys, here we go. So we're going to derive, it says, we know how to take the derivative of e to the x. With a few manipulations, we can find the derivative of its inverse function, ln of x. Where are we going? Well, let's see. Miss Cruz likes me to write, like, where we, like, the definition. Sorry, Miss Cruz, you opened your eyes really wide. You went like this, and you went like, no, you're not, Miss, whenever you having trouble. Make a note that the domain of your derivative is represented by the domain of your original function. Let's see if we can get there. All right, so I'm already telling you that the derivative of ln of x is 1 over x. That's what we're trying to get to. Oh, I didn't give you guys one. Let me. I thought I gave it. I'm kidding.
Like any athletic people can do it.
Oh, I just didn't give you. All right. Here we go. All right, you guys ready? So we don't know what this derivative is, but we know the.
That's the shop site. Not hers. Oh, I was like, oh, she's I'm fear.
Okay. Here we go. All right, guys, let's focus. So here we go. We don't know the derivative of ln of x, but we know the derivative of e to the x, and we know chain rule. So I can turn this into e to the y equals x. You see, if I put, because e and ln are inverses of each other, so if I do that, you'll get this. E to the y equals, and e to the ln, that just drops the x. So I get that. Does that make sense? Okay. So here's what I'm going to do. I'm going to put parentheses on this y there, because I think it'll be easier for you guys. What's up?
And you just multiply by e so that you get rid of the ln.
Well, I didn't multiply. I raised it. E to the y, e to the ln of x. They're inverses of each other, so you just drop the x.
So we're trying to get rid of the ln.
Well, we don't know the derivative of ln, but we know the derivative of e. The whole point is because we don't know the derivative of... Do you know the derivative of ln x? No. I mean, I guess we can look at it here, but we don't. But we know the derivative of e to the y. What's the derivative of e to the x? E to the x. So we know the derivative of e to the y. All right, so here we go. You guys ready? So I'm going to write d dx. So I'm taking the derivative with respect to x. Whatever you do to one side, you do to the other. So the derivative of e to the y is going to be itself, e to the y. Good job. E to the y. And then chain rule, then I got to take the derivative of y. So the derivative of y is y prime, but can I just say dy dx? Yes. There it is. That's chain rule. E to the y, dy dx. Do you guys see what we did there? Equals, what's the derivative of x?
No.
With respect to x. 1. Right? The derivative of x with respect to x is 1. The slope of, if I were to say y equals x, the slope of x is 1. Okay. I wasn't sure if you got that in there. Does everyone got that? Okay. Here's what we're going to do. I'm trying to find the derivative, so that means I'm going to get dy dx by itself. So how do I get rid of that e to the y? Divide. Divide. So now I have this. Dy dx equals 1 over e to the y. Are we okay? Now I don't want it in terms of y. Remember, look at this in the blue there, where I wrote e to the y equals x. Well, I can replace this e to the y with a what? X. So there it is, guys. Dy dx equals 1 over x. See? So so what does that mean? If this is y, if y equals ln x, then dy dx is 1 over x. And that's the derivation of the derivative of ln x. So if you see d dx of ln x, you're just going to say 1 over x, like that. Now here's chain rule. If you use differential function with respect to x, so d dx of ln of u, then you're going to say 1 over u, and then to the side you're going to write du dx. Do you see what we did, guys? Okay. Any issues? Okay. So now we're just going to practice taking a derivative. And you're going to see, you can use log rules. You're going to see tomorrow that it's probably easier to use log rules. So look at this, and I'll do it both ways. So according to this says to do this. It says, let's see, I'm taking a derivative. 1 over x cubed. Have I lost anyone? No. And then chain rule. Then I got to multiply this by what?
2x.
No, not 2. No, not negative. Just 3x squared. Because it says du dx. This is my u.
Oh yeah, that was me. I thought I saw 2.
Yeah, that's a u there, right?
I thought it was x squared.
So 3x squared over x cubed. What cancels out? How many x's cancel out?
2.
2. And now you just have 3 over x. What? I mean, I guess if you wanted to, x to the negative 3. Well, I'm not bringing it up. But you could, x to the negative 3 times 3x squared, and you'll still get the same answer, 3x to the negative 1. Right, when you multiply exponents. You're saying this is x to the negative 3 times 3x squared. That's 3x to the negative 1, which is the same thing.
But I mean, like, why is why is like 3x squared like just not like why is that just
Because it says here du dx. So that's, if this is my u, see, if u equals x cubed, then 1 over u times, and then du dx is 3x squared. So you go times 3x squared, and then replace back what u is, which is x cubed. Did you see that? Okay. All right, guys, I just want to bring this to your attention. You could have used your log rules. You see this? So let me rewrite it. d dx of ln of x cubed. You could have used your log rules. You see this 3 right here, guys? I could have moved that 3 right in front like there. Okay? And if I did that, yeah, you still get the same answer. Look, d dx of 3 ln x. And then you could have said, okay, well, that 3 is just a constant. It's 3 times that. So you could have said 3, and then what's the root of ln x? And look, you get the same answer, 3 over x.
So basically, if we see like ln of
Bless you squared.
u squared or x cubed or x to the 4th, we should automatically just be able to say it's whatever the power is over x. Like we should be able to just like those problems.
Oh yeah. Because if you do your log rule, 3, yeah, that's fine. But if you do chain rule, you'll get the same answer.
Okay. So like if that question like there, you won't worry if there's work or not, right? It's just like
Yeah, that's fine. Because
we recognize it.
yeah.
Okay.
Cool or not cool? All right, tomorrow you're going to get a circuit, and some of you, relax, circuits are fun. And you're going to see this, and you're going to be thinking, oh, I'm going to do quotient rule with the inside, and I'm going to do chain rule. And you're going to thinking, oh, 1 over that, so x minus 1 over x squared times, and you're going to go bottom times root of the top, minus top times root of the bottom, 2x, all over bottom squared. Which is, by the way, true. You can do that, and then this just means take the reciprocal, right? But you're going to have to do a lot of algebra to get the answer that the circuit has. Which, do you want to do a lot of algebra, guys? No. Well, we will do a lot of algebra, but not yet. All right, so here it is. Oh, man, I deleted that. That's fine. So here's what we're going to do. Ready? Expand this with log rules. d dx of ln of x minus 1. And look, it's over x squared, so I can write it minus ln of x squared.
Oh, like we used to do.
Yeah, just log rules with pre-cal. Do you guys see that? And now, when you take the derivative, okay, now I'm taking a derivative.
Behind, right?
Say it again.
2 behind the ln, so that
You can put the 2 in the front if you want, but I'm going to leave it there. 1 over x minus 1 times 1 minus, yeah.
2 over x.
Yeah, that's going to simplify to that, yes. 1 over x squared times 2x. One of the x's cancel out. Do you guys see that? Yeah, it doesn't matter how you do it. If you want to go Houston's route, Houston just said, oh, I'm just going to use my log rules. Put the 2 in the front. And the derivative of ln of x is just 1 over x. So that's how she got 2 over x really quick. And there it is, guys. So that's my derivative. 1 over x minus 1 minus 2 over x. And that's what you're going to, look, put a asterisk on that one. You're going to see it again on your circuit tomorrow. And then when you see it, I mean, you can ask me for help, but hopefully you'll be like, oh, Travis was talking about this one yesterday. And then you just answer it real quick. How do we feel? Okay, let's do one more. I'm gonna put it here on purple, and I guess we can talk about the restriction of the domain, but I'm just gonna leave it like this: ddx ln of sine x.
Wait, we got this job.
All right,
Hear me out.
I am. I'm hearing you out.
Tell us, Mickey.
Tell us.
Hey, that's good. That's good. Okay. So what I think is 1 over cosine x.
No, 1 over u, which is this, right? That's your u. 1 over sine x, and then you do chain rule times, what's the derivative of sine x? Cosine x. So we're going to get cosine x over sine x, which is an okay answer. Is there a better answer? What is it? Cotangent x. Do you see how we did it? Okay. All right. Here we go from 2008. So relax before we set you guys loose for this question. Bless you squared. Oh, that was a good one. Bless you cubed. Bless you fourth powered. You got one more? Okay. 40% of the total population got this question correct. 36% of the threes, 51% of the fours, 72% of the fives. So this, I guess, is considered a hard question. What's the difference between a 4 and a 5? Probably questions like this. The 5s are usually getting it correct, while everyone else is flip up a coin. Does that make sense? So take 2 minutes. See if you guys can figure this question out. Everyone has the snuffles. Did you do that first?
Yes.
Okay. I'm trying to take the derivative of this. Whatever you do to one side, you do to the other. So here we go. Equals, and I'm going slow. Yeah. Chain rule. So what do I do first?
Put the 2
2.
in front of the ln of x.
Good job, miss.
And you find the derivative ln of x, which is just 1 over x.
Plus.
You're funny.
That plus is this plus, right? No. I'm just taking the derivative of this.
So 2.
2.
ln of x.
No, what's the derivative of ln of x? 1 over x.
Oh, that's right.
It doesn't have a variable in the 2, so you don't do product rule. You just do 2 times 1 over x. You know what I mean? And there it is. And let's make it pretty. 2 ln of x over x plus 2 over x. The denominators are the same, so I can rewrite this as 2 ln of x plus 2 over x. Do you see how we did it, guys? Ask me, Houston.
I thought this 2. Wait. Oh, because. Never mind. I got it.
For sure?
Yes.
For sure, for sure.
Yes.
All right. Ask me. What's up? You're good? Ask me, miss. Ask me.
I just have to look at it, but I have to get it.
I have a question. So, you know how it says the derivative of this, and then just go to 3 over x? Why is it 2 ln of x times 1 over x? Like, why is the ln of x still present if it was still present?
Well, it's a derivative of ln of x. Or you're talking about this one, the one on the left? Well, that's chain rule.
It's like the same
Take-
reason why we do why we have sine, like say we're taking the derivative of sine x to the power of 2. It's the same reason why we have 2 sine x.
Oh, it's because the 2 is not just attached to the x, it's
It's-
attached to the whole argument.
Yeah, so
Okay.
you're good?
Yes,
Yeah.
I see right.
Yeah. So hopefully you remember, guys. Do you remember how ln of x minus 3 looks like? That is a horizontal shift of ln of x 3 times to the right. So if I do that, the original ln of x has a vertical asymptote at x equals 0. But this one has a vertical asymptote at x equals 3. It looks like that. That's how f of x equals ln of x minus 3 looks like. So the domain, before I do anything, the domain is x greater than 3. And I guess if you want it to be a robot, you can just say, oh, well, the expression on the inside has to always be greater than 0. And then just move the 3, x greater than 3, see? So there it is. I already stated the domain of the derivative. And now we're just going to take the derivative of that. Like, why is that important? Well, the derivative of ln of x minus 3 is 1 over x minus 3. And this function is a rational function, so this has domain all real numbers except for 3. So all real numbers except for 3 is not the same thing as x greater than 3. So that's why it's good practice to state the domain. We don't always do it, guys, if I'm being honest. Usually, like, I don't know if I didn't tell you guys this, but notice that sine x, I put ln of sine x. Well, the sine x goes between -1 and 1. So this, like, we'd have to say restrictions for this because you can't have a negative argument inside your ln, right? So we'd have to probably state something like absolute value of sine x or something like that. So, or we're just,
Sorry.
go ahead.
So if we had if we had like negative sine x in there, we would have to find.
Oh, it doesn't matter. Negative sine x, positive sine x. So remember that sine x goes between -1 and 1. So we'd probably have to put a restriction like absolute value of sine x. And we're just talking about strictly where sine x is greater than 0. Probably something like that. And then, of course, that means cosine x. We also got to talk about we're just talking about the positive values.
Will we use that a lot?
We sometimes don't even mention the domain. We just find derivatives. But you'll see. All right. I think that's enough about that. This is probably what's hardest to you guys. I'm not going to say that it doesn't come out because it does. Does it come out a lot? It does not. But it does come out. So I just want you guys to be aware. So do you guys remember this? Sometimes they call that the change of base formula. Okay. So here we go. So I'm gonna do a hack. So here's my hack because we don't know the derivative of this, but we know the derivative of ln of x, right? So I'm gonna do a hack and I'm gonna write d dx of this equals d dx, and I'm gonna turn this into this right here. See, d dx of ln of x over ln of a. Okay, are we still okay?
So that is equal to log base a of x.
Yep.
Okay.
And then I'm gonna say d dx, and I'm gonna bless you. Ln of a is a constant, so let me write that down. Ln of a is a constant. So I'm going to write it like this. 1 over ln of a times ln of x. And this that I just circled is a constant. Are we still okay? All right.
And how do we know it's a constant?
It's just ln of a, so it's not x.
Okay.
So as long as it's not x, it's a constant. Or you can also see it here too. See the base there? Okay. All right. Are we still okay, guys? All right. Here we go. This is a constant. I'm taking the derivative of this. Leave that constant alone. It's not an x. 1 over ln of a. And then what's the derivative of ln of x? 1 over x. So 1 over, and usually you put the x in front of the ln. And there it is. That's my derivative.
That's all you do?
Yeah, that's it. So what is it for chain rule? Oh, I didn't put it in here. Oh, I did, but it's in the very... Okay, let's see if we can figure it out. D dx log base A of u. Now, when I say that u is differential with respect to x, this is what I mean. This is not u times x. This means that u is a product. U is not a product. U is a function of x. You know what I mean? Okay. So the derivative of this, according to this, is 1 over u ln of A. And then on the outside, times what I put on the outside. Chain rule. You're close. Du dx. So there it is. This is your rule, guys. It does come out. It's worthy of knowing it.
Just like off the top of my head.
If possible, yes. We're okay?
Yes.
All right, we're just going to use it. That's all we're doing. So come over here to this next page. And this just wants the derivative c. It says, as stated previously, if u is differentiable function of x. So I'm just rewriting it again, just so we can know it, so we can know that we know it. 1 over u ln of A, and on the outside of this, write du dx. We're just following that rule. We're okay so far, guys? I know. It's still too early in the morning. So first thing I'm going to do is state the domain of f prime. I know that the expression or my argument, 3x plus 1, must be greater than 0. So 3x must be greater than negative 1. Are we still okay, guys? X must be greater than negative 1/3. So there's my domain. Are we okay so far? All right, I'm going to go slow. F prime of x. All I'm doing is following this rule right here, guys. So the 3x plus 1 is your u. So I'm going to go 1 over what? Yeah, 3x plus 1. Close it. And I'll put ln of what? Ln of 2. Am I done? No. Times the derivative of u. What's the derivative of 3x plus 1? 3. So my final answer, f prime of x, is equal to 3 over, make sure to put the 3x plus 1 in parentheses, ln of 2. If you don't put parentheses in the 3x plus 1, it's going to be kind of wrong. Are we okay, guys? Okay. From delta. So these are the type of questions you have on delta. It wants me to find the derivative. What two rules do I got to use here?
Chain and product.
Yeah, product and chain. Well, I guess maybe not so much. I guess maybe it's my fault because I said two. Product. And we'll see if we have to use chain. You guys ready? So f prime of x equals first. So negative 2x squared. I'm putting the negative with the 2x squared. First times the derivative of the second. So there it is, log base 2 of x. So look, here's my formula. Let me zoom out so I can see my formula. So I'm going to write 1 over x ln of 2. Yeah, you can say ln of 2 first, but usually you want to put the x in the front, times 1, so you don't have to worry about that. Plus or minus? Plus second log base 2 of x times the derivative of the first. What's the derivative of negative 2x squared? Negative 4x. Now, let me give you a heads up. Delta does not want you to, well, it doesn't say to simplify, but you can leave it like that. But UH, do you think UH is going to be nice? No. UH is going to want you to simplify. They're going to have A, B, C, D, and they're going to make you do common denominator and all that good stuff. When we get there, we'll get there. Maybe tomorrow we'll do, or who knows, maybe a little bit I'll not log in if you guys want to do some more. Yeah, you know what? Yeah, let's continue. Let's continue. Negative 2x squared over x ln of 2. And notice that you can factor out, or you can cancel out an x in a little bit. Minus 4x log base 2 of x. Now this is, yeah, UH will not have this answer like that. Yeah, of course not. You're funny, miss. This right here, they're going to have that written like this. ln of x over ln of 2. So do you guys want me to continue, like to simplify it? Yeah. All right, so one of these x's cancel out. Bam, bam. Negative 2x over ln of 2 minus 4x ln of x over ln of 2. Oh, okay, I got lucky here. See how they're both ln of 2 in the denominators? I can just, yep, good job. Your algebra is getting stronger, miss. I don't know if you can tell, but I can tell. 4x ln of x all over ln of 2. And be careful with this negative here. Sometimes it floats out way out. Make sure that you can tell it's with the negative 2x there. Or factor out the negative completely and make sure to put it way out in the front. Does that make sense there, guys? Okay. Don't we just got one more? Relax. I had to give you a quotient 1 from delta, so that way we're good. Do you have to simplify it on delta? No. Oh, you said that one angrily. All right. Bottom times root of the top. Bottom. Started from the bottom, now you're here. So, bottom, root of the top. What's the root of 3x to the 4th? 12x cubed. Tough crowd. Plus or minus? Minus top times root of the bottom. Now the root of the bottom, I have a base on it, so I'm going to write what? 1 over x. No, not log. Actually, you can make a case for log, but right now it's just ln. ln 3 times 1, so there it is. All this is over
Log 3 of x.
Perfect. Do you have to simplify? No, you can leave it alone. Well, the derivative of x is 1, but you don't have to. And that's it, guys. So now you just do a whole bunch of practice on delta, and we'll call it a day. What's up?